Hey guys, welcome back. So in the last video, we saw some of the examples of algorithm runtime complexities, whereby we saw order of n, order of log n, order of n, and so on. We also tried to plot all the time complexity on a graph and tried to analyze how one time complexity is different from another complexity. I hope the entire concept was clear. Now in this video, let's see how we can calculate the time complexity of a given algorithm. So as we have seen in our introductory video that there are two types of algorithm. So we will take two examples. One is an algorithm which is iterative, and then we'll take one more example of an algorithm which is recursive. So finding a time complexity of iterative algorithm is very simple. So we'll take that first and then we'll deep dive into recursive algorithms. So let's get started. So here we have a 1D array which is an unsorted one, and our task is to find the biggest number in this array. So the algorithm is very simple. What we are doing is, this is the name of the method, find biggest number. It takes the array in which we want to find the biggest number. It initializes the biggest number variable with the value in the first cell of the array. Then what it does is, we create a loop from the second cell onwards and loop till the last cell. And if the cell which we are currently pointing to is more than the already known number, in that case we update the biggest number variable, else we will move on to the next cell. So this loop continues from the second cell and goes on till the last cell. Once the loop terminates, we finally return the biggest number variable. Fine, now let's see how we can find the time complexity of this algorithm. So the first statement over here is assigning the value which is there in the first cell, put it into biggest number variable. So this will take a constant time. So we have put it as order of 1. Next we have a loop which starts from 1, goes on till the length of the array, that is the last cell in the array. So it essentially traverses all the cells in the array. So how many cells are there in the array? Total n number of cells are there. So it will take order of n time. Now you might be wondering that it should be order n minus 1 because we are starting from 1 and not from 0. So that is a valid question, but when we are dealing with a numbers like n, we always avoid the constant numbers. So 1 in this case is a constant number, so we are avoiding it. So what that means is order of n minus 1 is same as order of 1. Or even if we say order 2 into n will again be same as order of n. The reason is again the same, that is 2 over here is a constant and we can always safely eliminate it. Fine. Now the next statement is we are comparing the value of the current cell with the biggest number. So this is a constant time operation. Now updating the value in the biggest number variable is again a constant time operation. So if we add both of this, we get again order of n. Now you might say it will be order of 2 because it is order of 1 plus order of 1. So again the rules remain same. If we have a constant value, we can always put it as 1. What that means is if we have order of, let's say 20 or 10, we can say it as order of 1. Or even if we have order of 1000, still we can say it as order of 1. And the reason is 1000, 10 or 20, all these numbers over here are constant numbers. So now when we multiply order of n with order of 1, we get order of n. Now the final statement is returning the value in biggest number variable. So that is a constant time operation. Now if we add up all of this, what we get is order of 1 plus order of n plus order of 1. So this comes to order of n. Now why we are saying order of n and not order of 2? Because this order of 1 and this order of 1 are constant and we can safely eliminate them. Now let's quickly see why do we eliminate these constant numbers. Are not they important for us? So let's see that. Now let's say this order of n over here, the value of n is 1 billion. That means it takes 1 billion unit of time to process this 1 billion numbers. Now if we say order 1 billion plus order of 1. Now does this order of 1 stands anywhere any chance in front of 1 billion? Of course not. Because if we add this 1 in 1 billion or if we take out 1 from this 1 billion, it hardly makes a difference. Hence, whenever we have a time complexity which is in terms of n, in those kind of cases, we always eliminate the constant complexities like order of 1. Because the constant complexity does not stands any chance in front of order of n, which can always be a very huge number. Fine. So I hope you have understood how to find a time complexity of an iterative algorithm. So what we have done is all the operations which were constant operations, we have put it as order of 1. And wherever we have a loop, depending on how much time or how many time the loop will be running, we have put over there as the appropriate complexity, which is order n in this case. And then finally we have added all of the individual statements complexity to arrive at the final complexity of the entire algorithm. Fine. So now in the next video, let's see an example of finding time complexity of a recursive algorithm. Thanks for your time. See you in the next video.
Please subscribe, like, and share our channel. Keep supporting us.